All right, here we are. It's Wednesday, March 10th, and we're starting in on the last of our big differentiation rules, and that is the chain rule. It just makes life that much easier. So let's start with a recollection, as usual. And I have a couple problems from the JIT book on this, but this is just to remind us. So we're going to start by let f of x and g of x be differentiable functions. So then the composition of f and g, written f little o of g of x equals f of g of x. So this is how you compose two functions. And you learned this in Math 100 as well. So let's look at some examples here. So we're going to let f of x be the sine of x, and g of x is x squared minus 4. So we'll look at a few compositions here. So f composed with g of x is f of g of x, and this is what? This is the sine of, look at some colors in here. So it's the sine of g of x, right? So g of x now becomes the input of f of x. And so this becomes the sine of x squared minus 4. Okay. If you wanted to compute g composed with f of x, this is g of f of x, and this is g of sine x, which is sine x quantity squared minus 4, and rewriting it sine squared x minus 4. Okay. All right, so what we want to know now is what's the derivative. So note, if I take the composition of two functions and I compute its derivative, it goes like this. So you take f prime of g times g prime of x. And this is the chain rule. And I always want to think of f as being the outside function. So you take the derivative of the outside function, fix the inside, and then take the derivative of the inside function. So here's an example. Let h of x be the sine of x squared minus 4, which is what we had above. So h prime of x is going to be the cosine of x squared minus 4. So now we've done outside in times the derivative of x squared minus 4, and this becomes the cosine of x squared minus 4 times 2x, and we always put polynomials out front. And there it is. Right. So you always want to think outside in, outside in. Okay. The outside function in this case is sine. The inside function is x squared minus 4. So here's another one. I'm going to let y be 3x squared plus 1 squared. So the outside function is squared. So outside function is x squared, and the inside function is 3x squared plus 1. So dy dx is, so again, we're fixing this and take the derivative of the outside, so it's just the power rule. So it's 2 times 3x squared plus 1 times the derivative of 3x squared plus 1, which is 2 times 3x squared plus 1 times 6x, and that's 12x times 3x squared plus 1. All right, so this is Newton's notation, f prime g prime, and it's important for us, especially in the near future, to also understand how to do this with the Leibniz notation. So it's the same operation, it's just different notation, right? And so what Leibniz said, let y equal f of u, and then u equals g of x. So f of u is f of g of x, and that's the composition. And then the chain rule says the derivative of y with respect to x is the derivative of y with respect to u times the derivative of u with respect to x. And this is the chain rule that we use when we're doing related rates, which are coming up, and they are incredibly challenging. But if you understand how these derivatives work, then it makes life much easier. Okay. All right, so let's look at some not so clear compositions. Right. So for example, if you let f of x be e to the 2x plus 1. Hold on, let me change this notation here. We're going to let h of x be e to the 2x plus 1. Now, h of x is the composition of two functions, f and g of x. The outside function, and if you could see me, I'm doing quotes with my fingers. The outside function is e to the x. So, and the inside function is 2x plus 1, right? So this is f of g of x, which is e to the g of x, which is e to the 2x plus 1. Okay. Now, if you've ever done any sort of computing, like with Pascal or Python or MATLAB, instead of using e, they like to use, so instead of writing e to the x, they write the exponential of x. So it looks like an actual, like a sine function or a cosine function. And when that's the case, then what you have here is the exponential of 2x plus 1. And that makes the inside-outside concept much, much clearer. Okay. All right, so in general, and this is we'll use this a lot. In general, if h of x equals e raised to any function g, then h prime of x is e to the g of x, that's inside out, times g prime of x. Right? And we use this a lot. So for example, if y is equal to e to the 2x plus 1, y prime is 2 times e to the 2x plus 1. If y equals e to the x squared plus x, then y prime is equal to e to the x squared plus x times 2x plus 1, right? If y equals e to the sine x, then y prime is equal to e to the sine x with the derivative of the sine, which is cosine out in front. Okay. If y equals e to the pi x plus e, then y prime is equal to pi times e to the pi x plus e. Okay. And in each one of these, I really busted this pen. Ugh. In each one of these, shit. This is the G, and this is the G prime. And the e to the G stays fixed. Alright, so let's hit you with some guided practice before we meet. Problem 1. Find y prime if y equals 2x minus 1 to the 5th, 2. Find f prime of x if f of x equals the square root of 1 minus 2x, 3. Find y prime if y equals, this is a fun one, sine t over 1 plus cos t quantity squared. And that should be enough. I will see you in a few minutes.